Well, good afternoon and welcome everyone to our first webinar of the Boundary System Task Team. My name is Marjolaine Krug and today I'll be moderating this webinar on behalf of the Boundary System Task Team. So this task team is an initiative led by the GOOS Ocean Observation for Physics and Climate panel, the OOPC panel. And the main objective of the Boundary System Task Team is to provide guidance for both existing and planned sustained observing system at ocean boundaries. So today's webinar is the first in a series of 6 virtual dialogues on boundary systems. And the objective of the virtual dialogues is to learn from mature ocean observing systems to guide the deployment of observing assets at ocean boundaries. So in these dialogues, we see the involvement of the modeling community as essential to identify knowledge gaps and inform on the observing system design. And you'll see that each of the webinars includes presentation from both the observing and the modeling community. So just before we get started, I'm going to remind you of a quick outline of how this webinar will be run. After my introduction, we'll have an overview of the presentation by Dr. Enrique Alvarez Van Hoel, and then some guided discussion for 20 minutes, and then open discussion for 20 minutes before we close the webinar. So before we start, I would like to thank Dr. Enrique Alvarez Van Hoel for being a pioneer in the Boundary System Task Team webinar series and stepping forward to present on both the observing and the modeling components of the Iberian system. So Dr. Van Hoel is head of the Physical Oceanography Division at Portus del Estados, and he has a long experience of leadership and management of the observing and modeling system in the region. He's also got much experience dealing with stakeholders and their requirements. So we're very fortunate and grateful for the contribution to the series. And thank you so much for joining us today. And I think we can get started. Dr. Van Hoel, if you don't mind just getting started with your presentation. Thank you.
Hello. Thank you very much for your kind words, and especially thanks to the organizing team for giving me the opportunity to be the first one in this series. I like very much this idea, and I hope that everything will work smoothly and will work fine for the interest of the audience. So I will summarize in the following minutes my presentation that it's already recorded, and I hope you have had the opportunity to watch in advance, because this time I'm going just to highlight a few key messages with some of the slides I presented. So this is the index. I will talk a little bit of the framework at Spain for operational oceanography, how we reply to that from Portus del Estado with the Portus system. I will say a few words about the observing, the modeling component, the downstream services, and drive some conclusions. So the relevance of marine physics on daily life at the Iberian Peninsula. This is a video from an overtopping on a large storm in year 2008, not the largest one, but certainly a large one in the Mediterranean Sea. And you can see this is not a tsunami. This is not a, this was an ordinary storm that produced this kind of overtopping. This day, there was 3 casualties in Catalonia. For example, last year we had Gloria storm, which produced 11 casualties. So we are surrounded, Spain is basically together with Portugal, basically an island. We have high seas, both at the Atlantic and the Mediterranean coast, large tides, storm surges, which are producing inundation and coastal erosion. We have high frequency oscillations, phenomena like tsunamis, meteo tsunamis, infragravity waves affecting our ports and our coast, producing damages in coast and loss of life. And we are in a very exciting oceanographic area with a boundary system having, for example, important upwelling phenomena in the Galician coast, the poleward current going towards the north from Portugal, Galicia, and continuing through France to the north in the winter time. We have the interchange of water between the Mediterranean and Atlantic with this very sophisticated, very complex system, the oceanographic system that is happening at the straits with the internal waves, all these exciting physics that are going on there. And then we have, for example, also in the Alboran Sea, the classical Alboran gyres, the two big gyres that are almost permanent in the area. All these phenomena, which is the main focus of our networks and of our models, are impacting several socioeconomic sectors. For example, we have fisheries, we have shiprouting, tourism, wind energy generation, maritime safety, search and rescue, and also very important, we have the science. We are collaborating with many friends around in Spain and outside Spain in using our data to understand what is going on the ocean. So our data, maybe not, maybe only marginally by my team. It's being massively used by the Spanish and the international community of researchers. Is being used to address all these topics. For example, you see there the water change, the water interchange in the Straits of Gibraltar. You see the climate issues, many open aspects that are being studied with our data. The Portus system is basically consisted. It's an integrated system. We like to think on it like from the very beginning, from many years ago. It's an integrated system with several components, mainly the ocean monitoring component, the ocean modeling component, and all this goes together for the downstream where we have our tools for the users. With respect to the observing system, we have a really large network of instrumentation operational around the Spanish coast. We have 25 buoys, 39 dead gauges, 20 meter stations. Those are funded by Portus del Estado. And basically, it's a top-bottom design to monitor the different phenomena that I was explaining in the introduction. And we are, of course, collaborating with our friends in other institutions via that interchange through Copernicus Marine in situ tag. We have data since the 80s. So this is a few examples of the network. This is the deep water buoy network, large instrumentation moored at depths larger than 400 meters. The tide gauges, the high frequency radar network, and all this contributes to the in situ tag. In fact, Portus del Estado is leading the coordination of the in situ tag in the Iberian Biscay Ireland region. So we are also in charge of integrating all the data from several institutions in the region. With respect to modeling, we are working on two different scales. On the regional scale, our focus is mainly done on the Copernicus environment. We are working with Mercator Ocean, International, and other institutions in modeling at this scale. And then we have a specialized work in very high resolution, producing extremely high resolution models for the ports. All this, as I explained, go to the downstream services for the ports and other users. This is an example of the animation of the model we are running in the Copernicus system. This is the EBMFC, Marine Forecasting Center model. What you can see here is the SST and all the beauty and complexity of the mesoscale circulation on the Atlantic waters. And the colors correspond to the sea surface temperature, and the arrows correspond to the currents. And basically, this is a living book of dynamical oceanography. If you know a little bit of the area, you will start seeing all the characteristics that are described in the books. Like I see, for example, the higher temperatures in the Bay of Biscay, which are very characteristic. You see the upwelling, you see everything, all the basic patterns of the circulation there. A part of the circulation that you are seeing in this video, we have the wave system and the biogeochemical modeling for the same domain. Of course, this is not sufficient for the port, so we need to do this high resolution numerical modeling. We have 30 systems for circulation, for example, for the ports. We are dealing with our users mainly from the ports through a loop, which includes the research and development, the selection of products, the development of products of high resolution, then the identification of new needs, and after that, again, the R&D planning. So this is a loop that we execute approximately every 4 years. We do one of these loops. And by this way, we are able to provide more and more products to the ports. We call it the Samoa, which is the name of the project, the big project. Well, it's more than a project; it's an integrated project composed by several projects. Of course, all the products that we generate are being served for the society and for the ports, and those are our main tools to distribute the data to the society. The Portus system, I really would like you to have a look to our webpage. We have around 8,000 users daily, and this is the IMAR app, which is available for download on both Android and iOS systems. So as conclusion, Portus is a unique and very integrated system, including modeling and observation, with a really well-established dialogue with users. Why are we being successful? This is important because we are maintaining these networks for 3 decades now, and those are, to be honest, expensive networks to maintain. And we are being able to do that because the data of the network is needed, and we are fitting our products for purpose because we have a very good dialogue with the users, and there's a very well understood need of what we are doing. Coastal and port activities are more and more dominating our internal work because every year we are more needed at the coastal and at the port system scale, while the regional activity is being more and more done in our collaboration in our framework of activity with Copernicus Marine Service, with Mercator Ocean International. Obviously, all our systems are relying on previously a strong R&D. Our way of doing this R&D is traditionally through associated EU projects. For us, the EU projects have been of paramount importance to maintain our system up to date. We cannot imagine our system without the advances being produced on those EU projects. We have done, especially in the last decade, very huge effort, a really huge effort on the developing of good downstream application. This has demonstrated very important to increase the impact of the investment that we have done in the last decades with our instrumentation and modeling system. And of course, our results are serving the whole oceanographic community, are serving for the science of the whole oceanographic community. And we cannot also imagine and our work without the collaboration with many partners. You can see here a small subset of them, some of the classical friends that are working with us. But of course, our system cannot be understood without deep collaboration with many other institutions and European projects. So I hope I was able to summarize very fast my presentation of the other day. Thank you very much.
Thank you very much, Enrique. So I'm going to put forward a few questions that we have put together from the boundary system task team, just to expand a little bit on what you have provided through your presentation, which I really enjoyed. So thanks again. I'm not sure we get a sense of all the observations that are actually serving the system, because the presentation is focused on what is funded through Portus and designed to serve the port authorities. So we would like to know what other observations are serving the system, in particular beyond. Most of the observations are surface. So what are the subsurface and shelf slope wide observing in the region?
Well, we are using basically all possible available data in one way or another. For example, in our activity of numerical modeling at the large scale, we are, of course, using the Argo data to assimilate as part of the data assimilation process into the EBMFC system. And also we are using that on different time scales, of course, for the validation of the system. So Argo is a critical component for the numerical modeling effort we are doing on the regional scale. Also, there are other coastal observatories around Spain, and we of course participate in those, and we of course get information from these coastal observatories. We have, for example, the Raya project in Galicia and the Ocaso Observatory in the Gulf of Cadiz. We are collaborating with these observatories, and also, for example, with the SOCIB and the ASTI systems in the Basque Country and on the Balearic Island. So, as I mentioned, for example, on the modeling work especially, we are really making use of any possible available data.
These include, for example, sustained surveys by gliders or this kind of things?
Yeah, but I don't think those are reaching still the degree of a number of data. Of course, we are making use of that, but I think that the impact of this system will certainly increase in the future when the number of observation will increase. I think that today the main source of information for our system are with respect to depth data, not subsurface data, is the Argos system.
Thank you. And these observations of the Portus, they are assimilated into the CMEMS models, and then you use those models to then downscale to the scale that you're interested in.
CMEMS models are assimilating satellite data and Argo system. For example, our buoys and our tide gauges are considered independent, which is good to have some independent data source for validation. It's very good that not all the data are assimilated into the system, because you have then the possibility of validate your system. On the other hand, it's very difficult for a regional scale model to get benefit from assimilation in single points. So it is basically the benefit of larger scale data sets such as satellite data and Argo, the ones that are going into that simulation system today.
Okay, so on your regional scales, you don't really assimilate the real-time observation that you're collecting through the Portus system?
No.
Okay. There was another question still on the observing system on how the Strait of Gibraltar, is monitored by Portus or other institutes, because this article has a large impact.
Well, we are extremely lucky of having an HF radar system on the Straits of Gibraltar, which is providing a really beautiful data set to be analyzed. Then there are other institutions working in the area, like University of Malaga. They have a long-lasting ADCP profiler on the area. University of Cadiz is doing a lot of campaigns in the area. And we have a buoy at the entrance near the Gulf, near the Algeciras Bay. And in the past, we had a very, very nicely located buoy, but that was retired after so many accidents. Unfortunately, that one was retired. But from our contribution, our main contribution today are the tide gauges in the area, because we have tide gauges at both sides of the Straits of Gibraltar, which is really nice to understand the geostrophic circulation there. We have at Ceuta and we have at Algeciras, so at both sides of the Straits, and we have the HF radar, which is really nice to have there.
Thank you very much. Still related to the observing system, we were wondering in terms of the design of the system. How was it decided where to put the buoys, where to put the HF radars, and how was that process? How did that unfold?
Well, if you look onto the distribution of the buoys, you will see that they are very well distributed all around the Iberian Peninsula, together with our colleagues from Portugal. And this obeys really to a top-bottom design. At a given moment, well, the first network of buoys was the coastal buoy network, and the problem with the coastal buoys is that the wave parameters are only representative of a small portion of the coast. They are only representative of the place where the buoys are located. So at a given point, the need really grow of having wave values in deeper waters. So those wave values are representative of larger coastal areas. This was the initial main motivation of deploying the deep water network, and it was distributed, designed top to bottom. Of course, once you are placing instruments in such interesting locations, many of them are located on the slope, then you want to incorporate additional instruments. For example, you want to introduce current meters in order you are able to study the poleward current, you are able to study the upwelling events, and so on. Other networks were less well planified, let's say. For example, the HF radar network, we have been placing radars depending on the fundings that we were able to get. It was not a top-bottom approach, but more opportunity approach. We took our best opportunities with European funds, with projects to grow this network. And of course, we knew from the beginning that the Strait of Gibraltar was a good place to have HF radars. And through European projects, we got these HF radars. It's the same thing for Galicia, and we were building, let's say, in a more disorganized way the network. So it's not the same story for all networks.
Yes, thanks. I think that's really interesting. I was wondering, Enrique, if you could tell us a little bit about how the observation are used by the stakeholders, because the main stakeholders being the port, but I'm sure the observation are beneficial to a wide range of also stakeholders as well. Do you keep metrics on the frequency of access, the usage of the data by individual ports or users? And do you know there's some types of observation are used more frequently than others? Would you be able to comment on that?
We try to get an idea, permanent idea of how our observations are being used, and the impact of what we are doing is very clear when we are having, for example, a storm, and then the measurements of our networks are on all the TVs, on all the newspapers. People from TV came to the offices for interviews, things like that. When there's a big storm, you know that you are going to have a busy day at the office. But there are, let's say, I mean, in terms of number, it is clearly the waves, the best-selling product. Our best-selling product is, in fact, in terms of number of users, is the wave forecast. But I don't want to measure everything only in terms of numbers of users. For example, one of our best users is SASEMAR, which is the search and rescue institution in Spain, and they are using our circulation models or circulation data for the oil spill forecasting, for the trajectory forecasting, and they are searching for people drifting at sea based on our data. So how do you measure the importance of your data? Is it more important 2,000 surfers going to enjoy to the beach, or one single responsible of search and rescue trying to make somebody survive an accident? It's an interesting question, certainly, but it is clear that the numbers are pointing out that the wave is the most important thing, but it's not the only way to measure. You have to look into other things. And certainly our data is being used for all kinds of purposes. We have from the very normal to the most bizarre ones. For example, we have been asked for data to investigate crimes because they found a body in a certain area and they wanted to do, by the way, very efficiently, the police wanted to do a tracking study of how the body could have drifted if it was dumped in a certain place, if it was possible to find it in a given area. So it's really used and really very different users.
Thanks very much. So I'm just going to jump into another question, which actually is related, because you say waves is one of the things that is used very widely. So would you say that wave observing and forecasting for coastal region is a general gap in our global ocean observing system?
Sorry, I was not able to listen. Can you reply, please? Repeat, please.
You have highlighted waves as one of the very used data. And would you say then that wave observing and forecasting for coastal regions or boundary systems is a general gap in the GOOS capacity?
I think that wave forecasting and monitoring is critical. Of course, I would not talk about a general gap, because there are huge imbalances in the way these and other parameters are monitored and forecasted in the different areas around the globe. What I can say for sure is that any activity, any country that have a coast will have an important socioeconomic activity on the coast, as for sure, and for sure most of the regions will be affected by the waves. So certainly monitor properly the wave and forecast properly the waves is very important. And you cannot get that only relying on satellites, because with respect to the waves, the repetition cycle of the satellite is not sufficient to capture the stream events, all the stream events. So you need at least this 1 hour sampling period in order to capture properly the stream events that are the ones that are interesting.
Thanks. Dr. Van Gool, in terms of the design of your observing system and the assessment of the observing system, have you been able to review the observing system? How do you decide on adding new components or removing certain components? Have you been involved in OOPC experiments to test which observations benefit the system the most?
We have been involved in OOPC studies, and our data have been involved in some of these, but to be honest, the decisions coming from this were never affecting the design of our network. As I mentioned, the buoy network was designed from a top to bottom approach, and the changes that we have been done in the station are more related to the technology inside the buoys than to the position of the systems. We have during those years changed many things inside the buoys in order to go in parallel with the changes in the technology. We started with certain sensors for the waves, and now the sensors for the waves are using a completely different technology. The processors inside the buoy, the communications from the buoy to the land, everything has changed during the years. But of course, we want to maintain the position of the measuring stations as long as we can, because there is also a big value on the long-term time series. We need long-term time series for climate studies. So we really try not to play much with the position of the buoys, because and of all the instruments of the system. We try to keep it as stable as possible. Same thing can be said for the tide gauges. The tide gauges, I explained that on the longer presentation. It's of paramount importance, the change that we have made in the terms of sampling frequency. At the beginning, the tide gauge were measuring once every 5 minutes. Now they are measuring with 2 Hz frequency, twice per second. That has completely changed the range of application and the range of science that you can do with the tide gauges. We have very recently presented a paper that is showing that infragravitatory waves can be produced in the Mediterranean due to the waves in the same way they are being produced on the Atlantic. And this is something that was, I mean, it was not forbidden, but usually we were not considering this to be happening. And during this last storm, Gloria, that I mentioned it briefly, there was very long period waves, and there was an effect of infragravitatory waves being produced as we usually observe on the Atlantic. And it could have been impossible to detect this and to analyze this without this technological change in the dive gauges.
A very interesting point that I took from your presentation. I think it's a good thing to note for anyone who wants to design a system to serve port authorities or other things. The one question that I had in terms of the modeling component, where you mentioned that one of the big issues is capturing the eddies, the eddy flows. Where do you think that the models struggle the most? Where are they failing the most? And what would be an approach to resolving that? What sort of observation could improve on how they resolve these processes?
Well, first of all, we have to limit the field where the models are struggling. The models are struggling in areas where mesoscale activity is dominant. If you go to the North Sea, or if you go to the Straits of Gibraltar, where you have a very strong tidal component, then the models behave really well. Then also the models from, let's say, the statistical point of view, if you want to know the average current in a certain area, again, the models work very well in all kinds of seas. I mean, the mean statistical current can be perfectly captured by can be well captured by the models. You are struggling when you want to know the specific current at a specific date, a specific hour, in an area which is highly dominated by the mesoscale activity. And this is very simple to understand when you look into the map and you see the size of the mesoscalar fields or structures in the ocean, and you see that those are 30 kilometers, 20 kilometers, 50 kilometers structures. And how many instruments do you have there to be able to properly characterize this front and initialize your model with this front? You have maybe one satellite pass on the region that happens a few hours ago. On the same time, the atmospheric modelers are dealing with structures that goes, for example, from Spain to the UK. That's the size of the front. So the difference is from structures that have thousands of kilometers to structures that are 2 orders of magnitude smaller, that have tens of kilometers. So there's a serious technological limitation to deal with that, because we cannot have, with the present measuring technology, the data that we need for this. We cannot imagine to increase the number of Argo buoys or to increase the number of buoys to a number sufficient to cope with that. Maybe we can in the future imagine that technology on the satellites gets small enough to have clusters of satellites in the same way they are launching clusters of satellites for communication now, like the ones by SpaceX now. Why not imagine this kind of constellations of satellites for science and for oceanography? Of course, this has the problem of destroying the night sky, which is very nasty. But I think that we need a technological leap in order to properly obtain this kind of simulation, thanks to the data simulation that we provide. Of course, there are a lot of advances also in using the satellite imagery together with trying to compute the Ekman winds or something similar in order to compute the geostrophic velocity and then adding the wind velocity on top of that. There's now a Copernicus product that is able to do that, And this is a very interesting product, but of course it's not producing a forecast. It's just to analyze data from the past. So we have work to be done for the next decades.
Yes, yes. So before we move to the open discussion, because we're reaching the end of this guided discussion now, I'd like to just ask you briefly if you've got any recommendation for those who are wanting to develop an observing system for their regions.
Well, my recommendation would be to understand what are the problems they want to deal with, and make sure you deploy your system with your proper users under your wing. So you go together with your users from the very beginning. Those could be scientific users, those could be socioeconomic users, could be ports, could be, I don't know, depends on the region and depends on the problem of the region. The big problem with observing system is the long-term maintenance. This is the most difficult and the most important problem to solve. And I will strongly encourage everybody that is thinking about that to go together with the long-term interested user. Is the way the system will survive the scientists that are developing it.
Thanks. And I think this is actually a great way to end, because it ties perfectly with the first questions we have on our question board. Please, any participant, put your questions through the question board so we can put them forward. I'll start with the first question, which is exactly linked to that. It's asking, how did you manage to convince the Spanish Port Authority into funding such a big-scale long-term initiative?
Well,
it's quite a feat. Well done on doing that.
Well, using a lot of our time. That's the short reply. We are really trying to be at their service as much as we can, and associated to this Samoa loop that we do every 3-4 years. Associated to that, we do a campaign of visits to the port. So every 3-4 years, we split the ports, the number of ports, the 48 ports that we have in our system, between our team, and we say, okay, you go to that port, you go to that port. We arrange our visits, trying to combine our touristical interest with our professional interest, and we visit all the people on the ports. We do presentation, we ask for need. We do also from time to time some questionnaires about satisfaction with the products, inquiring for new products to be developed. So that's the answer: working and having interest and keeping a permanent contact with the people. Of course, it very much depends on the guy on the other line of the telephone. With some of the ports, we have been able to develop a really powerful collaboration, and other times we have not been that successful. You need really some people which has interest on the other side, and this vary a lot from port to port.
Thanks. I've got a question here from Dr. John Wilkin on your whether you've used your data simulation system to identify relative impacts of different observations. You have touched upon this in our previous discussion, but maybe you can expand a little bit on how you've used your data simulation models and why they weren't, you know, the results didn't actually impact on the design of the system.
Well, first of all, they didn't impact on the design of the system because the design of the system was done 10 years before we started any data simulation activity. So that's a historical reason. Second, we of course rely on data simulation for our large for our large-scale circulation in the framework of Copernicus. We are working with Mercator Ocean in that. In fact, we are using the data simulation system that has been developed by Mercator Ocean. It's exactly the same one that they are using in their global model. And we are doing the data simulation basically on the deep water. We are not assimilating any data on the shelf, so we are confident that the benefit from the data assimilation in the deep water is moving to the shelf water, which sometimes is the case, but it's not that clear that it's always the case. So as I said, in this field there is plenty of room to improve.
Yes, I would like to ask you a question about the data assembly centers, because you highlight the value of regional data integration activities of the Portus system here contributed to the eModNet system. Would you advocate for regional data assembly centers for respective boundary systems to be something, something we should do?
If I advocate, sorry, can you repeat the question?
Or would you think advocating for regional data center would be important?
Yeah, I certainly this is a need. More than I don't need to advocate, because I understand this is really a need. We cannot work isolated, and it's very well structured through GOOS and through the RUSES, the regional units of GOOS, which are translated into Copernicus system. You have the in-situ tag organized in the same RUSES that GOOS, and at the end, all this data also goes to eModNet, and it's the same data that you can see on eModNet. Nevertheless, once I have said that, I must say that there is a risk, and it's not solved yet. Unfortunately, it's not solved yet. And the risk is that the data integrators are somehow not on purpose, because I'm absolutely convinced it's not on purpose, but they are somehow hiding the participation of the national centers that are actually collecting the data. And this is extremely dangerous for the system, because at the end of the day, it's the national system most of the times the ones that are getting the data. But I can tell you, for example, talking now from the Portus del Estado side, that I have seen papers done with our data, only using our data, completely paper from a third party, only using our data, which is great. I like that, but they are not mentioning Portus del Estado at any place. They are only mentioning Copernicus, the data integration. And this is something that is extremely dangerous, because this is one less point that I have to justify with the society, with my bosses, with the people that is putting the money to sustain the buoys. I have one less tool to justify the money that is being put into the system, because we are deleted from that. I think this is something to be seriously taken, and it's something that I don't think is the guilt of anybody. It's not something that is being done on purpose, but we have to be more careful as a community with the acknowledgement of the data providers, certainly.
I think that would be a very valid recommendation going forward. Thanks for that. There's a question here from Deborah about how the regional observing modeling systems have they provided any new insights into changes in climate variability and climate change?
I think this is certainly the case. On one hand, as you know, we have to work on regionalization of the services. This is really done through data in C3S, the Copernicus Climate Service. But going strictly to the Copernicus Marine Service, for example, we are now working, I can tell you that this is quite fresh, that we are now working on the climate change evolution studies during the last decades, using the reanalysis of Copernicus together with the satellite data and our buoy data. So we are putting together into a paper now a study using these three data sources, trying to understand the changes in sea surface temperature around the Iberian Peninsula on the last decades. And we are seeing that, of course, the three sources have differences, but we are demonstrating the value of the Copernicus data to explore these kind of things too, especially of the reanalysis, not of the forecast, of course. You know that we have in Copernicus the forecast product, but we have also the reanalysis product that covers several decades of data.
Thank you. Professor Johnny Johannesson is asking what part of the system are weakest and in need of most priority development and advancement?
That's a very good one. The weakness part is the human resources. Unfortunately, I think this is a common problem to many institutions around the world, and this is being really serious in our case. We were many years ago a young team of scientists, and years are passing, and we don't see enough renovation in terms of manpower for our system. So for me, the risk in the system is today mostly related to human resources.
Is it difficult to employ people to work on the system to motivate for job creation?
It is something that is not, I don't want to blame only my institution. I think it's something that is quite frequent in many places around Europe, and especially in Spain. And this is certainly an issue to be worried about.
Yes, thanks. I see that not only in Africa we're struggling with human capacity. So there's a question here from Dr. Galliani on are there any areas which cannot be improved much, even with more data, available data and modeling? So are there any areas which are just aren't really improving?
I don't like to think that we cannot improve with more data, but there are certain areas that demand more urgently improvement than others. Let's put it in that way. For example, the wave forecast is quite accurate, to be honest. And our capacity to monitor waves is more or less sufficient, although, for example, we don't have redundancy enough in some components of the system, and it could be the case that we are missing important events due to lack of redundancy. Of course, to maintain the buoys at sea is expensive, and it is difficult to justify that you are having two expensive devices on the same position just in case one of them fails. But that will be ideal, of course, because sometimes it is happening that I can tell you, for example, we have a winter a few years ago where we were under a chain of severe storms, one after another. That was an amazing winter. We have one storm after another, cloudy skies, and we were recording one huge event after another. And the problem was that since the sky was cloudy for 2-3 months, all the buoy system was starting to run low of battery due to the lack of solar input on the solar panels. So at a given moment, we say, okay, this is going to fail. Suddenly, the whole system in the middle of these events, and that will be tragic. And that was when we say that last day, there was a couple of sunny days just by a miracle, and the whole system recovered, and we were able to continue measuring the rest of the storms of the season. So of course, redundancy is an important fact, even if you have a good system like the one for the buoys. For other things, you have an absolutely insufficient system. Biogeochemical measurements, you have almost nothing. Many kind of even essential ocean variables like currents on the water column, you have very little thing even in very important areas. So waves is maybe the exception, and for the rest of the variables, we are really undersampling the ocean, really undersampling the ocean. So it's very clear.
Yes, we still have a long road ahead, I suppose. We've got a few more minutes left of this discussion. You mentioned in your presentation and even in your summary about the biogeochemical models that you are running. And I'd like to know, how has the physical observing system benefited the biogeochemical system, and how do you combine the physical observation together with other types of observation from chemical biological observation?
Yeah, the flow basically goes in the direction of physics feeding biogeochemical models. The model that we are running in the Copernicus framework is the PISCES model, and this one is using the output of the NEMO numerical model in order to do their computations of the biogeochemical variables. So the arrow goes in the direction from the physics to the biogeochemical component.
Okay, thank you. I'm just trying to go through the last few questions on the. I'm not very good with this menu. Okay, so one from Nadia Ayub asking about the design of the observing system is integrated with an international observational effort at larger scale. For instance, the monitoring of the eastern boundary current along the slope in the Northeast Atlantic. So yes, so how do you integrate your system within, I guess, global international questions, scientific questions, if I understand correctly?
We integrate that once the system is in place. Unfortunately, there is not a mechanism or an effort for the design of this observing system on an international scale. At least in our case, there are other examples in other areas of the world where this is working, but this is not the case here. And what we are doing is, once our system is in place and once we are recording all this information, we are of course sharing our data and sharing our information through in situ TAC and through EMODNet and through other initiatives. So all researchers in France, in UK, can explore these phenomena that of course are not constrained, not limited to Spanish waters.
Thanks. I think I've got time for maybe one last question, which is coming from Adriani Sunudin, who would like to know how the insight from your operational system and your continuous observation were applied into warnings for the potential risk and hazard to the coastal community.
If I understood correctly, because I have a little bit of noise here, is how we translate this data into warnings. Is that correct?
Yes.
We have two ways of doing that. First way of doing that is through our collaboration with the Spanish Met Office. The institution in charge of providing these warnings at a national level for all coast activities is the Spanish Met Office. So we are in contact permanent with them. We are providing all the data, and we are working together with them in providing this kind of alerts for the community. So they are using, of course, our systems for this purpose. And second is our port system. in the case of the ports, we have the legal obligation of being ourselves the one providing, it's on the law, that it's Portos del Estado the one providing the warnings to the specific warning to the port system. So for those, we have developed a specific and I would say quite advanced alert systems that allow the port to create alerts that are serving the whole port community to receive everyday information on what is happening with the mid-ocean environment. In fact, they can build through the tool that we have developed, and it's integrated in this Samoa project that I mentioned. They have built their own alerts, combining, for example, waves and winds and currents. They can work with alerts for the forecast, and they can work also on alerts for real time. So many of the ports around Spain are basically deciding their daily operation in terms of closing down the port due on the forecast that we provide to them. For example, Barcelona port does have an overtopping forecast that we are providing to them, and with this they can close certain areas of the port. And basically, many people on the ports, especially the guys taking this kind of decision, the first thing they do every day is checking the alert system. Well, in fact, they receive the alert on the email and the alert on SMS on the phones, and they can take the decisions associated to this. So we have this kind of semaphoric, highly configurable system that converts all our data into warnings for the whole port system.
Thanks, Enrique. I've just got one more question. This one's coming from me. I noticed in your presentation that you say you contracted the operations to a private company. And then I was just wondering how much private entities are involved in this project? You know, what is the balance between the public versus private companies serving the system? And how much of the system is used to further create opportunities for the private sector? Because I suppose you have to motivate in terms of also the ocean economy for the existence of your system.
Well, the first participation of the private sector, as I mentioned it on the presentation, is on the maintenance of the system, on the physical maintenance. So my team is specialized really on the treatment of the data, but we have not, let's say, electronic engineers, for example, in our team. So we need to contract those on the private sector. So we are only going at sea to, let's say, from time to time to control that everything is going fine, but it's the private sector that is doing that. So we have open biddings for every component of the system. We have one for the tide gauges, another one for the HF radars, another one for the coastal buoys, and the best companies are coming here to maintain the system. And it's, I have to say that this kind of arrangement is working pretty well. Second, we of course are also feeding the private sector for their own business. For example, all the engineering companies that are doing projects around Spain, they are using continuously our data, continuously. They are feeding into our webpage, asking us for raw data. So we are in the basis of a lot of activity associated to private companies that are doing business, for example, for design, and also in an increasing way, they are asking us for real-time data. I don't know, just to say an example of today. Today, we were asked by a private company that they are doing let's say a dynamic presentation on Barcelona with a huge screen in the city showing real-time data of atmospheric and cultural and oceanographic values and things like that. And they are getting the data from our buoy outside Barcelona, And today they asked me, do you have a long-term time series of this buoy? Because we could maybe drop information on climate change on Barcelona coastal waters. So this is the example of today. And it's a permanent flow of people coming to take benefit of this, which obviously is extremely motivating for us. The best way to be selfish is to share your data. That is clear. That's a clear message.
I like that. I like that very much. Well, thank you very much. I think we should close the discussion here. It's been really good chatting to you, and thank you so much for coming forward. And I would also like to thank all of you for coming today and attending this webinar, and in particular the WMO staff, Ms. Colin Forrest for assisting us with the webinars, and of course our OOPC secretary, Dr. Belen Martin-Miguez, who's been really a very dynamic force here. So all of these conversations are recorded and will be made available on the website, and you should receive a notification in the next few days informing you on how to access the discussion. For those who haven't had the chance to see the full presentation of Dr. Van Poel, please do so. It's really interesting. And just before we part, I'd like to say that our next webinar will be on the 6th of June, and it will be on the California current system. So we hope to see you there. Thank you so much, and take care.
Thank you very much for the opportunity. Bye-bye.